Hey, welcome back to my statistics class. Today we talk about how to draw a box plot. So here are the dataset. The dataset below represents 15 exam score for a fictional statistics class. We used this dataset before, and now we use that to draw a box plot. Okay, first of all, we need to connect the statistic, such as connecting the 5-number summary and calculate the IQR. So, okay, 5-number of we have minimum, Q1, Q2, aka median, and the maximum. Okay, so since there are 15 data points, so the Q2 would be what? The median, which is the 8th data. 1, 2, 3, 4, 5, 6, 7, 8. So this is our Q2. Okay, now the data has been divided into 2 equal parts. The first part in here, we find the median from the first part, which is this one. So 70 is going to be our Q1. And now we do the same thing for the second part of data. So the median would be in here, Q3. So we have Q1 equals to 17, Q2 equals to 82, Q3 equals to 94, and the maximum equals to what? Maximum is the largest number, 100, and then the minimum would be 31, the smallest number. Okay, IQR, interquartile range, which is equals to Q3 minus Q1, equals to 19.4 minus 70, equals to 24. So how do we draw the box plots? So the first thing is we draw the number 9 in here. We label it from maybe 20. Okay, so now what you do is draw a vertical line at the median, Q1 and the Q3. Okay, let's draw it. I'm going to use a blue pen. So Q1 equals to 70, which is here. That's our Q1. And then Q2, also median, which is 82. Remember, this is 82. And then Q3 is 94, which is approximated here. And then what you do is connect these from the box. You also want to find out where's the minimum and the maximum. In our data set, maximum is at 100. And then minimum is 31. Let me connect these with the box. So you know that inside the box, that's what? 50% of the data is inside the box. Okay, so the next thing is, how do we determine the outliers? So what made you think, hey, is it 31 is outlier or 100 is outlier? Or is 62 also outlier? We don't know. That's why we have a rule to determine it, which is we use 1.5 times the interquartile range on each side of the box to determine the fences. If it's the data outside the fences are considered outlier. Okay, so let's find it. So the upper fence equals to, let me use a different color of pen. Let's use pink one. Pink is my favorite color. So 19.4 plus 1.5 times of IQR, which is 24. In here, we did in our first question. Use a Google calculator or your scientific calculator. And we have our upper fence is 113. Lower fence is Q1, which is 17 minus 1.5 times IQR, which is 24. Is equal to 13.4. So usually you don't need to draw the fences. Now I'm going to use a dashed line to draw it so that we can see which data is outside the upper or lower fences. You don't need to do that. Okay, so this is our lower fences. And at 130 is our upper fences. So that means if the data outside of this part and this part are considered outliers. So now let's take a look. Which one are the outliers? So which data is less than 34 and which data is greater than 130? Okay, we only have one data less than 34, which is 31. And none of data are greater than 130. So that means what? 31 is our outlier. Sometimes you can have more than one outliers. Sometimes you just got one, sometimes you don't have any outlier. Okay, draw a whisker. Draw the line to the nearest data value inside of each fences to make a short vertical bar and label each value outside the fences. Okay, so now let's take a look. Instead of drawing minimum and maximum, I'm going to erase these parts. Okay, we need to draw the whisker. So what's whisker? So since fences doesn't exist, I'm going to erase this as well. Okay, so they told you that. Let me use the green, blue pen. So it's the nearest data value inside of each fences. Remember? So which is our fences? It's from 34 to 130. So what's the nearest data to 13.4? Let's look at our data set. So 13.4 is in here. So the nearest data would be 62. So we draw a 62 in here. That's 62. And then when it comes to another upper fences, the nearest data would be 100, right? 100 is the next data closest to 130. So we draw data at 100, which is here. So this call is called whisker. Okay, so now let's continue the examples. So continue our test score data set. Write a paragraph to describe the distribution and be sure to talk about the shape, center, spread, and any other unusual feature. So now let's take about this. We know that from the 5 number summary, we know that the median of the score, the median score, was 82. And what about the shape? I forgot the shape. The shape is what? Well, it's really obvious. It's not in the center. The tail, there's a tail. The 31 is dragging, there's a tail. So the tail is on the left side. So that means the data is skewed left distribute. Okay, and then how does the data spread? So the spread, when we talk about spreading in a skewed distribution, we use interquartile. So we can say interquartile represent 50% of the data, right? So we can say most of the score, which is our interquartile range, is between what? 17, 1 to 94. And then we also need to talk about unusual feature. We just proved that, hey, 31 is our outlier. So we can say there is one outlier with a score of 31. I don't have space. I right here. Okay, That's how you summarize the data. Okay, now take a look. Let me recap this. For a skew distribution, when talk about center, we use median because median doesn't affected by the outliers. And when we talk about spread, we use interquartile range. For symmetrical distribution, we use mean to describe the center and the standard variation to describe how the data spread. Okay, so that's it for today. We're going to see you next time and using the GeoGebra. Let me know if you have any questions.